Okay, so we're going to do SOHCAHTOA today, right triangle trigonometry. And we should already know sine, cosine, tangent. We already went over it last week, but today we're adding on the other three trigonometric ratios, which are reciprocals of the first three. So if you can find sine, cosine, and tangent, you can find cosecant, secant, and cotangent. All you do is reciprocate the sine, cosine, tangent. Now, where students will make silly mistakes is they will forget which one of these goes with the original. They'll forget that cosecant goes with sine, or that secant goes with cosine. Usually nobody forgets tangent and cotangent go together. Usually nobody forgets that one. So I have a little trick to remember which one goes with which, is if you look at the pairs, the reciprocal pairs, there's only one co per pair. So tangent and cotangent. Cosine and secant. Sine and cosecant. See, there's only one co per pair. So if you can remember cotangent and tangent go together, then you can remember the other two because only one co per pair. Do you understand what I'm saying? No cosine with cosecant. They don't go together. No two cos. Just one co. All right, so when you see a question like this, you say, oh, I have to find all 6 trigonometric values. So right away on your paper, you start writing sine, and then what is my angle? Theta. Theta. So I don't know the angle, but you still have to represent it. There's no time that you would ever write sine without an angle. Like, sine by itself is sin, not sine. We have no sinning in math, it's just sine. You have to put it with an angle. So cosine theta, tangent theta. And then immediately I'm also writing cosecant theta, secant theta, and cotangent theta. So they're already set up and ready to go. And I'm going to find the answers. So sine, we know, is the opposite of our hypotenuse. And I look at my triangle and I go, opposite is 3. Oh no, I'm not given the hypotenuse. Pythagorean theorem. You know, I could use the Pythagorean theorem if I wasn't extra observant and learned something in previous courses. It's a triple, right? It's a 3, 4, 5 triple. So since I noticed that the two shorter legs, or the two legs are 3 and 4, the hypotenuse will be 5. That's a triple if you don't know. Or if it's not a triple, then you use the Pythagorean theorem, which we will, and we'll do that in a moment. Before I move on and finish the rest of this question, can we list a few other triples just to have handy? You will have a non-calculator test or quiz, and I will usually use triples on that. So if you don't know the triple, that is 7, anybody know it? Actually, let me do that one next. 5, somebody said 12, 13, yeah. So if you don't know that, then you're going to have to like multiply 5 times 5 and 12 times 12 and figure out that, or whatever it is. What's the 7? Anybody know the 7? 24, 25. Who'd you have? Oh, she made you learn for geometry or for algebra? Who'd you have for geometry? She made you learn. Yeah. What's 8? Oh no, come on, what's 8? There's a 17. 15. That's usually the ones that I would put on a quiz or test. So I know in the past, and you know I give different forms. I know in the past I've given one test that had the 7, 24, 25, and like the other form would have the 8, 15, 17. And if you don't know those, then you're out there multiplying 17 from 17 like on your paper. This is non-calculator. If you know them, you're at an advantage. Okay, back to this. If I know that sine is 3/5, And then I know cosine is 4/5, and I know tangent is 3/4. How do I find these? I just look at those numbers and switch them and just hope that I did them right. So I don't memorize that cosecant is hypotenuse over opposite. I don't memorize that. I just find sine and flip it. The next one. Given that cosecant theta is 3/2, find the other trigonometric ratios. Okay, I gotta find them all, so I'm gonna start writing them all. Sine of theta, cosine theta, tangent theta, cosecant theta, secant theta, cotangent theta, cosecant is 3/2. So what else do I know? I know sine is 2/3. So what else do I know? I know the opposite and the hypotenuse. Now, I'm a visual person, so I draw a triangle. You don't have to draw a triangle. You should have enough information to find it. But I like to have the triangle there. So I'm going to draw a right triangle. I'm going to put theta wherever I want to. And then I'm going to put in, across from theta, the opposite is 2, the hypotenuse is 3. And then I'm going to say, I need to find the adjacent. Is there a triple with a 2 and a 3? No. So then I am going to do Pythagorean theorem. 2 squared plus what? Something squared, yeah. Equals 3 squared. Just make your 3 squared. Hypotenuse has to be in the C place. So I'm going to 4 plus b squared is 9, so b squared is 5, so b is square root 5. Square root 5 is our missing 5. So cosine is square root of 5/3. Tangent, I find, is square root of 5. No, it's 2 over square root of 5, sorry. 2 over square root of 5. And then we went over this already. We're going to go over it again and again. When it's in simplest form, we don't put square root of 5, or we don't leave any radicals in the denominator. So you can rationalize it. We rationalize by multiplying by square root of 5 over square root of 5. So you get 2 square root of 5/5. So when I talk about make sure you reduce everything for your homework, you have to rationalize stuff. Or if it can reduce, then you reduce it. Don't put an answer like 5/10. Put 1/2. All right, so secant, I've got to flip cosine, but what happens when I flip it? I'm going to have to rationalize again. So as many times as you end up rationalizing, you should probably start to be able to know how to do this in your head and not actually have to write it down every single time. So I get 3 square root of 5/5. And then cotangent, if I flip this one, I'm going to have to rationalize again and simplify. If I go all the way back to my original tangent and flip that one, oops, if I flip that one, it's going to give me less work. So I'm just going to go back to 2 over radical 5, flip that one to radical 5 over 2. Okay? Then the last example we've already gone over, so I'm going to have you take a moment and do it. Is it still going to be 6 minutes? Oh, yeah, even better. Oh, hey, that's not what I want to do. There we go. This last example, you have to find the sine, cosine, and tangent. You don't have to do all 6 trigonometric ratios. Just the sine, cosine, and tangent of 45 degrees, of 30 degrees, and of 60 degrees. This is something that you guys graded on Friday. We did it last week. Did sine of 45 degrees, like how many times? 12, I don't know. Did it over and over again. Let's see if you can find those. If you don't have them memorized, see if you can find them. I'll put the answers up in a moment. Remember, we're writing sine of 45 degrees. We're not just writing sine. And degrees has a degree symbol. If you don't put the degree symbol, I think you mean radians. You don't put the degree symbol, it means radians. And I know you don't mean that, but I'm going to take it like you mean it. Sound all right? These assignments in the book. You got a book, or you want to check them out, or you want to borrow one? Borrow one. For real, Leslie, how many times did we do the sine 45 degrees on that homework? Every single time, the sine of 45 degrees was the same answer. Every single time. The sine of 30 degrees was the same answer. The sooner that you know what they are, the better you're going to be. I'm putting the answers up. If you have checked your answers and you know this stuff, you can start on the assignment, which will be up here in a moment as well. It is also written over there. It's in the book. I have posted the book link on Canvas, plus the assignment is written on Canvas. Okay, that's it for today. I'm going to stop this video and then I can put this right back up.